All right, let's dive right in. Today, we're looking at a home project that's pretty wild. It takes the kind of heavy-duty storage tech you'd find in a huge data center and shrinks it down to something that can fit on a desk. It's basically a masterclass in building your own personal cloud, all on a budget.
And, that's the perfect way to kick this off. Because when you first hear about this setup, it really does sound like it just shouldn't work. It kind of flips the script on what we think is possible with regular, off-the-shelf computer parts.
So here it is. This is the heart of the whole thing. What you're looking at is just a stack of 7 little, unassuming computers. But here's the crazy part. Together, they're running software that was designed to handle petabytes of data across thousands of servers.
That's the big question we're going to unpack today, right? We're going to look at the hardware, the software, and maybe most importantly, the whole philosophy behind why you'd want to build your own tiny cloud from the ground up.
Okay, first up, the impossible home data center. Before we get into all the nuts and bolts, let's just take a second to appreciate the final product. Because this isn't just some random pile of parts. It's a real vision for what a home data setup can actually be.
You see, the whole goal here wasn't to get insane speeds. It was about chasing understanding. It's about taking these really complex, abstract ideas about cloud storage and making them real. Something you can actually touch, configure, and even break, all for the sake of learning something new.
So, what are these 7 little giants actually made of? Let's pop the hood, because the hardware choices are actually pretty modest, but also really, really smart.
Okay, so the secret sauce here is really balance. Each one of these 7 HP mini PCs has a capable Intel i5 chip, a very generous 32 gigs of RAM, and a nice mix of super fast NVMe and SSD storage. We're not talking about some old, dusty hardware from a closet. This is a carefully chosen, power-efficient setup that's just perfect for this kind of experiment.
And check this out. This is where you can really see the care and attention to detail that went into the build. I mean, it's not just about making it work. It's about making it look good, too. These custom brackets turn what could be a messy stack of computers into this clean, sleek modular unit. It just looks professional.
And I just love this little detail. It's such a great reminder that these kinds of projects are so often a community thing. It's not just one person tinkering away in a basement. It's a whole network of friends and fellow geeks sharing their knowledge and skills to build something awesome together.
Now, this is where things get really clever. Instead of having a messy rat's nest of 7 different power bricks and cables everywhere, the builder came up with this custom dual power supply system. It is such an elegant solution. It cleans everything up, it helps with airflow, and it just makes the whole thing feel more solid and reliable.
All right, so we've seen the hardware, but the real magic, the thing that turns 7 separate computers into one single, resilient storage pool, well, that's the software. So let's talk about the ghost in the machine, a piece of software called Ceph.
So here's the most important thing to get about Ceph. It's not just about storing files. This is a system that's literally designed for survival. It works by scattering your data across multiple machines so that if one or even 2 of them completely die, your data is still totally safe and you can still get to it. It is built for resilience from the ground up.
The best way to wrap your head around Ceph is to compare it to something you might already know, like RAID. A RAID setup in your computer protects you if a single hard drive fails. Great. But what happens if the entire computer goes up in smoke? That's where Ceph comes in. It spreads your data across the entire cluster of machines so it can survive one of them, or even several, completely failing.
And boom, that's it. That is the simplest and most powerful way to think about it. It takes that idea of redundancy that we use for hard drives and just applies it to whole computers. This isn't some niche concept. This is the core idea that powers massive cloud storage systems.
So, okay, we've got this incredible, super resilient system. But I know what you're probably thinking, especially when you look at those hardware specs.
Right? I mean, Ceph is known for being an absolute bandwidth hog. It needs really, really fast networking to work well. And this cluster is just running on standard, everyday gigabit Ethernet. So, can it even keep up? Is it actually usable? And this comment from the community just hits the nail on the head. The short answer is nope, it's not fast. Not at all. But that was never the point. The goal here wasn't to build a performance monster. It was to build a learning tool.
That is exactly it. This thing isn't trying to compete with Amazon's cloud. Think of it more like a living, breathing textbook. Every single blinking light, every network cable, every line in a config file is a hands-on lesson in how these massive distributed systems actually work. It makes the cloud feel a lot less abstract and a lot more real.
So after looking at all the hardware, the software, and the whole philosophy behind this thing, what are the key takeaways? What can we actually learn from this amazing build?
Well, there are 5 huge lessons here. First, networking is everything. This project proves that even with good CPUs and fast storage, a slow network will always be your bottleneck. Second, and this is a big one, consumer hardware is totally enough to learn on. You do not need expensive enterprise gear to get the basic principles. Third, power and cooling actually matter. That cool PSU hack wasn't just for looks. A clean, stable setup prevents all sorts of weird, hard-to-diagnose problems. Fourth, your community is a superpower. From getting advice online to a friend 3D printing parts, shared knowledge is a massive booster. And finally, making it look good inspires you. Seriously. A tidy, well-built project is one you're going to be excited to work on.
And that's really the ultimate takeaway, isn't it? In a world where we just rent most of our infrastructure from giant cloud companies, there is something incredibly valuable about building your own. It's not a simulation. It's a real, functioning system, and it's going to teach you things you just can't learn from clicking around on a web dashboard.
So, I'll leave you with this one final thought. This project took the invisible, abstract idea of the cloud and made it into a physical, tangible thing. And that makes me wonder, and maybe it'll make you wonder too. What invisible system out there could you build just to make it visible, just to finally understand how it really works?